Okay, good day. So for today's presentation, we will be discussing antiderivative, indefinite integral, and power rule. So this will be our first topic for the integral calculus. So the course of discussion. Okay, so for this session, so we'll start with introducing the definition of antiderivative, and then we'll cover the different theories uh, that we are going to follow in finding the antiderivative of a given function. And then afterwards, so there will be series of examples, illustrative examples, to show on how to use or on how to apply specific principle. Okay, so for the antiderivative, and then later on, so we'll have practice problems or test your knowledge problems. So we're in you can try solving, okay, so the given problem on your own, and then just pause the video before I even show the solution. So just to check so whether we understand, okay, or we got something so from what was presented. So to start with, so there is a question. So which of functions, so f of x, whose derivative is f of x is equals to 2x plus 1? Is it f of x is equals to x squared plus x plus 5? Is it f of x is equals to x squared plus x minus 100? Is it f of x is equals to x squared plus x plus 1 over 8? Or is it f of x is equals to x squared plus x minus pi? So which of the functions f of x, so whose derivative is 2x plus 1? Okay, so I'll give you some time to think. So out of the given choices, so which do you think? Okay, so which do you think so would have a different or a derivative of 2x plus 1? Okay, so is it option A, option B, option C, and option D? Okay, so if you had chosen A, okay, so your answer is correct. If you had chosen B, your answer is correct as well. And if you had chosen C, or even if you had chosen D, your answer is correct as well. Actually, okay, so all of these given functions so would have a derivative of 2x plus 1. Because x squared so would have a derivative of 2x, and x, its derivative is 1. And then 5, so which is constant, so its derivative is 0. So thus, the derivative of the function f of x is simply, so f of x is equals to 2x plus 1. And plus 5, so will be 0. So similarly, so we have x squared plus x minus 1000. So that is equivalent to 2x plus 1 as well. So in the same manner, so f of x is equals to x squared plus x plus 1 all over 8. So its derivative is 2x plus 1. And x squared plus x minus pi, so this is still 2x plus 1 because pi, so the derivative of pi is still 0. So that means regardless, okay, so even the given functions are totally different with each other, but in this case the difference rely only on the constant that is added or subtracted from the given function, so therefore its derivative will still be the same. So in anti-differentiation, okay, so in fact, so any function of the form f of x is equals to x squared plus x plus c, so where c is a constant, is an antiderivative of 2x plus 1. So when we say antiderivative, so that's just the reverse process of the of differentiation, or the opposite of derivative is the antiderivative. So in this case, so if we are given x squared plus x plus 5, so it will have an antiderivative of or if we are given a 2x plus 1, okay, so if we are given 2x plus 1, so its antiderivative, okay, so will be x squared plus x. So in the same manner, so if we have it just so happened that in this case, so the difference is just the plus 5, so the minus 1000 plus 1 over 8 minus pi. So in differentiation, okay, so once we have a given function and then we derive it, so the answer would be the derivative. So in this case, so the derivative so will be 2x plus 1. So reversing that one, okay, so if we are given the derivative, so which is 2x plus 1, so this is 2x plus 1. So same as for the second option, the third option, and the fourth option, so the derivative are all 2x plus 1. And then performing the anti-differentiation or finding the integral of that derivative, so it should go back to the original function. So in this case, however, if I am going to find the antiderivative of 2x plus 1, so it will just be x squared plus x. And I'm not going to have the constant part. Okay, so it's because it's just 2x plus 1. So the antiderivative of 2x plus 1, it's just x squared plus x. But in this case, so we have different constants here. So the negative or the positive 5, the negative 1000, the positive 18, and the negative pi there. So that is why, so for every given antiderivative, okay, so for every given antiderivative, so we always add an arbitrary constant c. So the arbitrary constant c so would correspond, okay, so to any value or to any constant, okay, so that we were not able to recover so after performing the anti-differentiation. Okay, so that's the importance of the arbitrary constant c. Okay, so that is to represent for any constant so that will be added to the given antiderivative. Okay, so in finding, okay, so in finding the solution of the given integrand. Okay, so to formalize our definition for antidifferentiation, so a function f is called an antiderivative or the same as the indefinite integral. Okay, so antiderivative, the indefinite integral, the integral, so those are just the same. So the antiderivative of the function f in the interval I, so if f prime of x is equals to f of x. So f prime of x, so that would be the derivative, so that will be equal to f of x. So the process of finding the antiderivative of a given function is what we are referring as the antidifferentiation or the integration. So the answer is the antiderivative or the integral or the indefinite integral, but the process on doing in getting the antiderivative and the indefinite integral is what we are referring as the antidifferentiation or the integration. Okay, so the process is antidifferentiation or integration, and the resulting answer would be the antiderivative or the indefinite integral. So our first theorem states that if f is a particular antiderivative of f on an interval I, so then every antiderivative of f on I is given by f of x plus c. So we just simply find the antiderivative f of x and then we add the arbitrary constant c. So that is to represent the constant. Okay, so any constant so which corresponds to the families of solution so for the given integrand. And usually, so the antidifferentiation or the integration process is denoted by the integral symbol. Okay, so this symbol so corresponds to the operation of antidifferentiation or the integration. So once we saw so this symbol, so that means we are to evaluate the integrand or we are to perform antidifferentiation or integration. And we read, okay, so this is read as the indefinite integral of f of x with respect to x is equals to f of x plus c. So wherein f of x is what we are referring as the integrand, Okay, so f of x is the integrand, so dx corresponds to the differential of x, or that is the variable of integration, and c would be the arbitrary constant or the constant of integration. So the notation that we are using for integration is provided here. So as long as we can see that symbol, so we are asked to perform anti-differentiation or integration. And we have set of rules that we will be following. Okay, so we have set of rules that we will be following for anti-differentiation. The first is the constant rule. So when I say constant rule, if k is any real number, then the indefinite integral of k with respect to x is the integral of k dx is equals to kx plus c. So meaning, if we are given, so for example, I am given just simply dx, so the integral of dx, our x here, so it's not written, so which is equivalent to 1. So therefore, the integral of dx is just simply x plus c. So similarly, so let's say I'll have the integral of 5 dx. So this is the same as 5x plus c. So that is the constant rule. Okay, so the integral of dx, so it's just x plus c. So if it is or a constant is attached to it, so the integral of 5 dx, for example, is equals to 5x plus c. So let's say, for example, so given any real number coefficient a, an integrable function f, so usually that is what we are referring as the coefficient rule. So as long as it has a numerical coefficient, so we can move out the numerical coefficient outside the integration symbol or the integral symbol. So let's say, for example, I am given as 1 plus sine squared x dx is equals to or that's it, dx. So if we are given an integral such as this, we can denote that 1 plus sine squared x, okay, so this one, that 1 plus sine squared x will correspond to our f of x. And then the 5 here, so would correspond to our coefficient a. Okay, so it's a numerical coefficient. So similarly, I can move out. Okay, so I can just simply move out 5 there, and then the integral of 1 plus sine squared x, and then dx. So that is what we are referring as the coefficient rule. As long as there is a numerical coefficient attached to a given function, so we move out. Okay, so we move out the coefficient, and then afterwards, so we just simply find the integral of the f of x, and whatever is the integral, we multiplied it back to a numerical coefficient, which is 5. Okay, so those are the two so far. Okay, so those are the two integration rules, the constant rule and the coefficient rule. The constant rule and the coefficient rule. So next we have the sum and difference rule. So for integrable functions of f and g, okay, or in this case that would be f of 1 of x and f of 2 of x. So if two functions are separated by plus and minus, okay, or a sum and difference. So if two functions if the integrand, okay, so is a sum and difference, okay, of two functions, so then so we can just simply distribute, okay, so the integral operation. So in short, so we can just take the integral of f of 1 x dx, and then afterwards, so plus or minus the integral of f of 2 x dx. So example of that, so will be, so let's say we are given the integral of 5x squared plus 2x minus 1 dx. So since there are three terms involved here, so but then so each term is separated by plus and minus, okay, so the plus and minus here, so I can rewrite this one, so using the sum and difference rule, as simply the integral of 5x squared, so for the first term, so then dx, and then the operation is plus. So sum integral of 2x dx, and then minus the integral of 1 times dx, so that would just be minus dx. So that is for the sum and difference. So we only have a rule, okay, so for sum and difference. But if the operation is a product of two functions, or it is a quotient of two functions, so for example, if I will have so let's say the integral of 2x over e raised to x dx. Okay, so if we have division here, so is it the same as the integral of 2x over the integral of ex dx? Okay, so it's not. Okay, so it's a division of 2x and e raised to x, an algebraic function, so divide it with the exponential function e raised to x. So although the integral is the integral for the combination of the two functions, so we cannot just simply distribute the integral on the numerator, the integral symbol on the numerator and on the denominator. That doesn't follow. We don't have such rule. So in cases like this, so there are different techniques on what to do, so before you find the integral. So we cannot distribute, okay, so we cannot distribute the integral sign if the operation is division. So we cannot distribute the integral sign on the numerator or on the denominator. Okay, so that doesn't follow. So similarly, so we cannot do this one. So let's say we have e raised to x and then sine x dx. So it doesn't follow that this is the same as e raised to x dx, then multiply it with sine x dx. So that's not equal. Okay, so there are two functions, so we cannot simply distribute the integral sign. If it is a product of two functions, so that is the exponential function and the sine x function, so a product of two different functions, we cannot just simply distribute the integral sign. Okay, so we can only distribute the integral sign if the operation involved is summation and or the sum and difference. Okay, so if it is sum and difference, we can distribute the integral sign. But then if it is a quotient or if it is a product, so it is not. Okay, so if that is the case, so there will be some techniques on what to do so to find the integral. Okay, so if it is a quotient or if it is a product. And lastly, so we have the basic formula. Okay, so for algebraic function, so we have the power rule. Okay, so for any real number n, so where n is not equal to -1, okay, so it could be n could be 0, n could be positive number, or it could be a negative number other than -1. Okay, so the indefinite integral x raised to n, so we use this formula. That is, so x raised to n plus 1 all over n plus 1 plus c. Okay, so we add 1. Okay, so instead of subtracting 1, so in the power rule for derivative, so we are subtracting 1, but the power rule for integral, so we are adding 1. So let's say we are given the integral of x cubed dx. Okay, so if we are given x cubed dx, our n here correspond to 3. So that's the integral of that. So it would be x raised to 3 plus 1 all over 3 plus 1 plus c. So which makes it x raised to 3 plus 1 is 4 all over 4 plus c. So that's how we use the power rule. Okay, so this is used for algebraic functions. Okay, so for polynomials, again, so as long as we have a real number, okay, so for the value of n. Okay, so those are the 4 rules. Okay, so again, first is the constant rule. Okay, so the integral of a constant is just simply the constant multiplied with x. Then for the coefficient rule, so we just simply move out the coefficient outside the integral symbol. Then for the sum and difference, so integration is only distributive for sum and difference operation, but not for multiplication or division. And then for the power rule, so as long as we have an algebraic function and then n corresponds to a real number other than -1, so we can use the power rule. And then the formula would just be x raised to n plus 1 all over n plus 1. Okay, so for our first example, so we will be providing the different steps on what are we going to apply. Okay, so in finding the solution of the given integrand. Okay, so our integrand here, so find the integral of 5x plus 7, multiply it with dx. As we can see here, so we have a given integrand, okay, so which is separated by plus. So that means I can use the rule, the sum and difference rule. Okay, so I can use the sum and difference rule. So in sum and difference rule, so we distribute the integral sign. So that is the integral of 5x, and of course, so there would be the differential x, just to denote that our variable of integration is x, and then plus the integral of 7 dx. So that will be our or using or applying the sum and difference rule. And then afterwards, so in here, so I can already use the constant rule. So for the constant rule, I can move out the constant. So I'll move the constant, that is 5, the integral of x dx, and then plus, okay, I can move out constant here as well, that is 7, the integral of dx. And then once we are done, so we can now integrate this one, so using the power rule. Okay, so for the power rule, so that is 5, and then the integral sign, we multiply it, okay, so with the coefficient, so x dx, so using power rule, our n is 1, so that makes it x raised to 1 plus 1 all over 1 plus 1. Then plus 7, so in this case, the integral of dx, that is just simply x. Okay, so integral of dx is x. And of course, so we attach our arbitrary constant. And finally, so we simplify this one, that is 1 plus 1 is 2, so that makes it 5 all over 2, then x raised to 2 plus 7x plus c. So that will be our final answer. So 5 all over 2, x squared plus 7x plus c. Okay, so that is for our first example. So we already applied the rules. So 1, 2, and 3. Okay. So we used the 3 rules already. Actually, so we use the constant and all of the rules. So not only the constant, so including the coefficient rule as well. So for example number 2, so we have the integral of 6x to the 4th minus 9x squared, and then minus the square root of x dx. So our first step, so we can use the sum and difference. So this would be simply the integral of, so 6x to the 4th dx, then minus the integral of 9x squared dx, and minus the integral of square root of x. So there's a radical. So we can transform this one into a rational exponent. So square root, so will become raised to 1/2. Then multiply it with dx. Then once we are done, so we can either use the constant and the coefficient rule. So we can move out. Okay, so since these are the first 2 examples, so we'll be doing it step by step. But as we proceed, Okay, so we do it right away. Okay, so the solution won't be long. So 6, the integral of x to the 4th dx, then minus 9, integral of x squared dx, then minus the integral of x raised to 1/2 dx. And lastly, so we can use already what the power rule. So applying the power rule, so that would give us 6, and then this would be x raised to, so again I can write this one, but later on I will be writing right away the answer. And minus 9, multiply it with x raised to, so 2 plus 1 all over 2 plus 1. Then minus, so this will just be x raised to 1/2 plus 1 all over 1/2 plus 1. And then we simplify this. So 4 plus 1 is 5. So that will give us 6 all over 5 x raised to 5. Then minus 2 plus 1 is 3. So 9 over 3 x raised to 3. And minus x raised to, so 1/2 plus 1. Okay, so in power rule, since we are always adding, so we are always adding 1. The best way on how to do it is, or in finding the answer, so this would be our formula. So that would be the numerator, we multiply it or we add it with the denominator, and then divide it with the denominator. So that's how we add for power rule. Okay, so for power rule only, since we always add plus 1. Okay, so if it is if we are not going to add 1, so we cannot use this formula. Like for example, in this case, so we have 1/2. Our numerator is 1, the denominator is 2. So that means the new exponent then, so would be numerator is 1, denominator is 2. So divide it with the denominator, which is 2. So it's equivalent to 3 all over 2. So as to have a faster writing of the solution, so that would be 3 all over 2 all over 3 all over 2. And finally, so simplifying our answer, so that will give us 6 all over 5 x raised to the 5th, then minus, so 9 over 3 is 3, then x cubed, so minus, so we have 1 all over 3 over 2. Okay, so that just simply the reciprocal. Okay, so what's the reciprocal of 3 over 2? So that will be 2/3. Then x raised to 3 over 2. Then we add c. And this will be our final answer. So we have 6 over 5 x to the 5th minus 3x cubed minus 2/3 x raised to 3 all over 2 plus c. By the way, so we can always check our solution, so whether that is correct or not, by simply deriving the antiderivative. So for example, in this case, I want to check so whether the answer is correct or not. So what I'm going to do is I'm going to derive the given or the answer, so which is 5 all over 2, so x squared plus 7x plus c. So deriving this with respect to x, that will be 5 all over 2, then derivative of x squared is 2x. Then plus 7, derivative of x is 1, then plus constant is 0. So thus, so 2 and 2 would be cancelled. This would be 5x plus 7 times 1 is 7, then plus 0. So we have the 5x plus 1, so which is the same as our original integrand. So that is on how to check so whether our answer is correct or not. So similarly, so we can do it here as well. So the derivative of the answer, so with respect to x, minus 2/3 x raised to 3 all over 2. That is the same as 6 all over 5. So derivative of x to the 5th is 5x to the 4th minus 3. The derivative of x cubed is 3x squared. Then minus 2/3. So derivative of x raised to 3 over 2 is 3 all over 2. X raised to 3 over 2 minus 1, that is just simply 1 half. So which is, so 5 will be cancelled out. So 6x to the 4th minus 9x squared. And then 2/3 and 3/3 or 3 halves will be cancelled. So minus x raised to 1 half. So we have the plus c there, so which is 0. So which is the same as the original integrand. So that is how you check. Okay, so to verify whether your answer is correct or not. So you derive it. So those are the first two examples. So let's proceed for number 3. Okay. So number 3 is what I am mentioning a while ago. In this case, there are two functions which are multiplied with each other. Okay, so there are two sets of function, although both of them are algebraic. So this is the second function. This is our f of 1 of x. This is our f2 of x. So it is a product of two functions. It's not a sum and difference, but rather a product of two functions. So y cubed, sorry, that's not f of x, so that should be f of y. Okay. So f1 of y and f2 of y. So we cannot just simply distribute the integral sign there. So but rather, if the operation is multiplication or division, so if it is possible to perform the operation, so to simplify it and then reduce it into a sum and difference, then do the operation first. Okay? So if there is a multiplication operation, if I can transform the function into a sum and difference, then do it. So just like this one. So I can distribute y cubed to 2y squared minus 3. So to transform this one into a separable or into a sum and difference. So y cubed times 2y squared, so that will be 2y to the 5th. Then minus, so y cubed times 3, so that is 3y cubed. Then multiply it with dy. So 2y to the 5th minus 3y cubed, multiply it with dy. So this time, so I was able to transform the product into a sum or into a difference. So therefore, I can now distribute. Okay, so in this case, I'm going to combine right away. So I'll have 2y to the 5th. So I can move out 2. Then the integral of y to the 5th dy. And minus, so 3 is constant. So I can move out 3. So minus y cubed dy. Then we perform power rule. So y to the 5th. So that will be 5 plus 1, so which is 6 all over 6. So minus 3, multiply it with y. So 3 plus 1, so will be 4 all over 4 plus c. So finally, so our answer so would be 2/3. So but then 2/3 is the same as, or 2 over 6 is the same as 1/3. So 1/3 of y raised to 6 minus 3 over 4 or 3/4 of y to the 4th plus c. So 1/3 y to the 6 minus 3/4 y to the 4th plus c. So will be our integral. Okay, so that would be the integral or the antiderivative of the given integrand. So that is another example. So example number 3, so it's not a direct application of the 4 rules, okay, or the integration rules, but rather, so we perform multiplication first through the distribution property, and then from there, so that's the time that we apply the integration rules. Example number 4, so it's the same thing, so it's still a product, okay, so product of the square root of x and then multiply it with x plus 1 dx. But then, so since this is square roots, I can just simply transform this first into a rational exponent. So before performing the operation, so that will be, so x, so remember, so when we are multiplying same base, so we just simply add the exponent. So 1/2 plus 1, so that would be 1 and 1/2, or that is 3 halves. So 3/2 dx, and plus, so the first one is we distribute here, so the second one we distribute it to 1, so which is the integral of x raised to 1/2 dx. X raised to 3/2 dx plus x raised to 1/2 dx. And then, so just like what I've mentioned a while ago, so if we have a rational exponent, so we just simply add the numerator and denominator. So we don't have that anymore. So that would be x, so 3 plus 2 is 5, and then copy the denominator over 2. And that would be 5 all over 2. And plus x, so 1 plus 2 is 3 all over 2 all over 3 all over 2 plus c. And we simplify this, so it would just be the reciprocal. So 2 over 5, x raised to 5 all over 2 plus 2 over 3, x raised to 3 over 2 plus c. Okay, so that will be our final answer. So 2/5 of x raised to 5 over 2, and then plus 2/3, so x raised to 3 over 2, and plus c. Okay, so for this particular example, so this is a test your knowledge example. For example, you are given this, so what is the first step, so for you to do? So what is the first step that you're going to do to answer this one? Again, so we cannot just simply distribute the integral on the numerator and on the denominator. There's an operation involved. So this time the operation is division. Our last two examples, the operation is multiplication. So this time around, the operation is division. So we cannot simply right away apply the integration rules, but rather there's an operation involved. So therefore, perform the operation first. Perform the operation first. So how will you do it? So this is the time that you need to pause the video and then try it on your own. So pause the video first, okay, and then try it on your own. Okay, so do not fast forward this video. Okay, so you need to practice what are you going to do first. Okay, so before even applying the integration rule. Okay, so you need to pause the video and then try to do it on your own. Okay, so welcome back. If you had tried it on your own, so very good. So very good for trying. So let's try to check now if what you did is correct or not. Okay. So as I mentioned a while ago, we cannot just simply distribute. Okay. So the integral operation on the numerator and then divide it with the integral of the denominator. So that's not the case. So but rather, so since there's a division approach or there's a division process here, so we are going to perform the division. So in this case, we have a binomial at the numerator and then we have a monomial at the denominator. So if that is the case, I can just simply divide this. So I can regroup this one into 5x squared all over x raised to 5 over 3. And the other one, then plus 2 all over x raised to 5 over 3. And multiply it with dx. So once you are done, okay, so we need to perform the operations involved. Okay, so we need to perform the operation involved. So in this case, so that will be, so we have the same base, we still have the same base, so this is x, this is x. So the exponent is just 2, the other one is 5 over 3. So since the operation is quotient, so for quotient, we subtract the exponent. Okay, so that is, so that would just be simply 5, okay, and then x, then we have 2 minus 5 over 3. And then we have plus, then 2. So this one, so we still have x. So remember, so if we don't have x here, this is the same as x raised to 0. So thus, this one will become, so 0 for the numerator and then minus 5 over 3 for the denominator. Or we just simply take the inverse. Okay, so of 5 over 3, move it up, so it will become negative. So now, we can distribute this one as simply the integral of 5, then x, so we have 2 minus 5 over 3. So take the LCD, so which is 3, so 3 times 2 is 6, minus 5, which is 1. So therefore, that is x raised to 1/3. Okay, so x raised to 1/3. So x raised to 1/3. So, and then we have plus, so 2x raised to negative 5 over 3 dx. So this is the same as 5, the integral of x raised to 1/3 dx, then plus 2, the integral of x raised to negative 5 over 3 dx. Then so we perform the power rule, so we just simply add the numerator and denominator. That is 5, multiply it with 1 plus 3 is 4, so x raised to 4 over 3, so divide it with 4 over 3. Then plus 2, multiply it with x raised to, so negative 5 plus 3 is negative 2, so negative 2 all over positive 3, and divide it with negative 2 all over positive 3. And this would be 5, multiply it with, so the reciprocal of that, so will be 3 all over 4, x raised to 4 over 3. Then plus 2, so the sign will still be negative, okay, although we're going to reciprocate it. So it still be negative 3 all over 2. Then x raised to negative 2/3. So finally, so the answer will be, so 15 all over, so 5 times 3 is 15 all over 4, x raised to 4 over 3. Then minus, so 2 and 2 will be cancelled out, so that will just be 3, x raised to negative 2/3 plus c. So this is fine. You want to make the exponent positive, so it's up to you. So it will become then 3 all over x raised to 2/3. But this is already okay. So 15 over 4, x raised to 4 over 3, then minus 3, x raised to negative 2/3 plus c. So that is, if you got the correct answer, then congratulations. Okay, so if you had some mistake along the way, that is fine. Okay, committing mistakes is fine, so we learn from there. So that's it. Okay, so for the for integration Okay, so for the four integration rules, okay, so constant rule, coefficient, the sum and difference rule, and the power rule. So let's proceed with the chain rule. Okay, so if you use chain rule in differentiation, so there is a chain rule as well for integration. So let's say for example, on a given integrand, okay, so we have in this case, so we have f of g of x. So once we derive this one, okay, so the derivative of g of x is g prime of x dx. Okay, so if in a given integrand there is a function involved, and then once I derive it, so it will show okay, so it will be able to get, okay, so the rest of the given integrand, then that is or that can be integrated by chain rule. Okay, so if I want to do it using the power rule formula, so instead of x raised to n, so this is the same as the integral of u raised to n du. So wherein u could be any function. Okay, so u could be any function in such a way that once I derive u, so I'll be able to get du, then the integral of this so will be u raised to n plus 1 all over n plus 1 plus c. Okay, so this is our objective here. It's actually the same as in x raised to n. Okay, so let's say we are given the integral of x raised to n, so dx. So it would appear here that our u, okay, so our u here is x, and our du is dx. So once I derive x, and then I was able to get, okay, so the rest, so which is dx, then I can just simply use the formula as x raised to n plus 1 all over n plus 1. But in this case, it's u. Okay, so u could be other than x. Okay, so the power rule kasi it's just for x, but then if we are given a certain function and then its derivative is attached to the given integrand, then we can just simply use the chain rule. Or sometimes we are calling that one a substitution. So we let for the value of u, and then we substitute, and then it is transformable into a power rule. Okay, for example, in this case, so if we are given the integrand 7x, multiply it with 2x squared plus 1 raised to 6 dx, there's an operation involved, okay, so which is a product of 7x. Okay, so right, so we have the first function, and then this is the second function, f2 of x, so which is 2x squared plus 1 raised to 6. However, this is a very tedious process if we are going to multiply this. Let's say we cannot simply distribute 7x to 2x squared because of the presence of 6 here. So before even the distribution, we need to expand the binomial term here, which is the 2x squared plus 1. So binomial, okay, we're going to expand this one. So with the power raised to 6, that is very long process. Okay, but rather, okay, if I am going to let's say transform this first into this way. So let's say this is equivalent to, so we have a constant 7, so I can move out 7, and then it will just be a product of x raised to 2x squared plus 1 raised to 6. So since the formula that we are using here is the u raised to n du, then is equals to u raised to n plus 1 all over n plus 1 plus c. So our idea here is we need to transform this given integrand, okay, so this given integrand into this format. So to do that, so I can see that this one, okay, so 2x squared plus 1 raised to 6 is the one similar to u raised to n. Kasi this is the one with power. Okay, so usually the more complex function So that will become our u. So our n here, so would correspond to 6. And then I'm going to, let's say u, so to be equivalent to 2x squared plus 1. And then our n, of course, is equals to 6. So thus, what I'm going to do is, I'm going to write first the u raised to n. So which is 2x squared plus 1 raised to 6. So that corresponds to u raised to n. And then, so this is the u raised to n, and then 7 was moved out. So what remains will be 7, or the x and the dx. So that is the one that we will be multiplying here. So which is the x dx. So 7, then the integral of 2x squared plus 1 raised to 6, multiply it with x dx. So in short, so this one corresponds to u raised to n, and this one corresponds to du. And of course, we have the 7 for the or for our numerical coefficient a. So now, we just have to make sure that this part is really the du. Okay, so to ensure that one, so we need to derive u. So we have u here, so which is 2x squared plus 1. So we need to derive this one. So the derivative of 2x squared is 4x. Then derivative of 1 is 0. So it's actually 4x dx. So to be the derivative. Okay, so now, if we're going to use the substitution, so this would be equal to 7. Then the integral of, so 2x squared plus 1 is this, so which is u. And then our n is still 6. Then the problem with this one, so we have x dx. But this is 4x dx. So in short, I need du over 4, so to make it equal to x dx. So du over 4 is equals to x dx. So thus, I'm going to transform this one as du all over 4. And since this is constant, so which is 1/4, so this is the same as, I can move it out, so 7 over 4, the integral of u raised to 6 du. So now, I can simply integrate this one using the power rule. That is 7 over 4, then multiply it with u raised to, so 6 plus 1 is 7 all over 7. Then plus c. So which is equivalent to, so this would be cancelled out, and just simply 1/4 u raised to 7 plus c. But then, we need to transform it back. So u is 2x squared plus 1. So this is the same as 1/4. And then u is 2x squared plus 1 raised to 7 plus c. So finally, so that would be our resulting answer. So 1/4 of 2x squared plus 1 raised to 7 plus c. So once we transform this one into the format of u raised to n du. Okay? So we can do the substitution here. So for that solution. Okay, so how about this one? So again, so it's a product of 36x squared and the fourth root of 6x cubed plus 5 dx. So what are we going to do? So similarly, so we're going to transform this one into this format, the integral of u raised to n du. So to do that, so first, I'll move out 36, so which is the constant, and then we have the fourth root. So that means that is our u. This 6. So we move this out, and then so this one would serve as our u. So 6x cubed plus 5, and then this is raised to, so fourth root, so that will be 1/4. So what remains are x squared and dx. So we multiply x squared dx. So now, so we let u to be 6x cubed plus 5. So our du then will be, 6 times 3 is 18, and then we'll have x squared dx. So 18x squared dx plus 0. Then again, so the difference, this is x squared dx, this is x squared dx. So that is du all over 18 is equals to x squared dx. And now, so we substitute. So 36, the integral of, so this is u raised to 1/4, multiply it with du over 18. So 36 over 18 then, the integral of u raised to 1/4 du. So we perform, so 36 over 18, that is 2. And then multiply it with u raised to 1/4. So u, 1 plus 4 is 5 over 4. Divide it with 5 over 4. Plus c. So which is just simply the reciprocal of 5 over 4 is 4 over 5. So times 2, that will become 8 all over 5. Then multiply it with u raised to 5 over 4 plus c. So finally, so that will be 8 over 5. Our u is 6x cubed plus 5, then raised to 5 over 4, and plus c. So that is for our 6th example. So this should be number 7. Okay. Sample number 7. So this time it's a division. So 2t cubed plus 1, then over t raised to 4 plus 2t raised to 7. So what, so far class, so you can notice, okay, that our u, or the degree of the u, is larger than du by 1. Okay, so for example, in this case, so this is our u, so the degree is 2, and then on du, our du, the degree is 1. So the difference is 1. Because, so once we derive it, we always subtract by 1. So that makes it suitable for power rule. So the same is true with this. So the degree is 3, and then this is 2. The difference is 1. So as long as the difference is 1, so most of the time, so we can use the power rule. So it's just like this. Okay, so we have, most probably this will become our u, so which is 4, and then the du is 3. So the difference of the 2 degrees is 1. Okay, so thus we can use the power rule. But the difference this time, so it's not a product, but rather it's a quotient. Okay, but then we can, if it is a quotient, we can make this one as a product. Okay, so we can make this one as a product. So by just simply moving up the denominator, so this is the same as, again, so for the format of u raised to n du, so the one with the exponent would serve as the u. Okay, so in this case, so that would be t raised to 4 plus 2t. And then 7, so since we move it up, so it will become negative 7. And then our du, so hopefully, so that would be 2t cubed plus 1, then multiply it with dt. So you have u raised to n, multiply it with du. So but then let's try to check. So our u here, so will be this one. So t raised to 4, so plus 2t. So we derive it, so we have 4 t cubed, then plus 2, then we multiply it with dt. So 4t cubed plus derivative of 2t is 2, so multiply it with dt. But looking at this one, so it's different. Okay, so 4t cubed plus 2 is different from 2t cubed plus 1. But then 2 is factorable. So we can factor out 2. So this is the same as 2t cubed plus 1 raised to dt. So this time it's the same. So we just simply divide it by 2. So 2t cubed plus 1 dt. And so this would be, so u raised to negative 7, and then 2t cubed is du all over 2. So we'll have then 1/2 and the integral of u raised to negative 7 du. So 1/2, so u raised to negative 7, so negative 7 plus 1 is negative 6 all over negative 6 plus c. And that's our answer then. So would be negative 1 all over 12. So u is t raised to the 4th plus 2t and then raised to negative 6 plus c. So we can have that answer, or if we want, so that will be negative 1 over 12 times t to the 4th plus 2t raised to 6 plus c. So either of the two, so we can have those answers. Okay, so lastly, okay, so for another test your knowledge again. So we have product. So one is raised to 5. Okay, so the other is 2x plus 1. Okay, so again, so you can pause the video and then practice on your own. So try to solve it. Then afterwards, so once you were able to find an answer, so go back to this video. And hopefully, so you'll get the correct answer. Okay, so you may do it on your own now. Okay, so again, so thank you for trying. At least, okay, so you did your part. Okay, so in trying to solve this problem, so applying this rule, so the u raised to n du, so we can see that our u is 3x squared, so plus 3x minus 5. So therefore, so this is the same as, so 3x squared plus 3x minus 5 raised to 5. Then multiply it with 2x plus 1 dx. So we derive this. So that will become 6x plus 3. And then multiply it with dx. And since this is not the same as this one, so we factor out 3. So since 3 is common, so that will be 2x plus 1 dx. So thus we have du over 3 is the same as 2x plus 1, multiply it with dx. Okay. So now, so we can transform this. So 3x squared plus 3x minus 5 is the same as u raised to the 5th. Then multiply it with 2x plus 1 dx. That is the same as du all over 3. Or that's the same as 1/3 the integral of u raised to the 5th du. Or simply, so 1/3, so u raised to 6 all over 6 plus c. Or 1 over 18 u raised to 6 plus c, or 1 over 18. So u is 3x squared, so plus 3x minus 5 raised to 6 plus c. So 1 over 18. So 3x squared plus 3x minus 5 raised to 6 plus c. So that will be our final answer. Okay, so again, congrats if you were able to get the correct answer. So that means you understand, okay, so what we had discussed. But if you miss something, so don't be disheartened. Okay, so that's part of the learning process. Okay, so sometimes we commit mistakes, and we can repair that one. Okay, so through constant practice. So again, so there will be you can try. Okay, so you can try solving. Okay, so you can try solving. We have a lot of examples on our module, so you can try solving those problems. So the solution is already provided there, so don't look at the solution. So try it on your own first, and then once you have your answers, so that's the time that you cross-reference it to the solution, so which is provided on your Canvas module. And hopefully, okay, so you'll be able to master on how to use and when to use the power rule, and when to just simply use the 4 integration rules. And that will be all from me, so for today. Okay, so I hope you learned something, and I hope everything will be clear. Okay, so make sure that you master this, because we will be using this throughout the semester. Okay, that will be all. Good day, and God bless always.